Today we're going to be looking at probability. So at the top we see a little scale from impossible to certain. So when we're talking about probability, the chances of something happening. I have a 6-sided die in my hand, and so the probability of me rolling it and it landing on a 7 would be impossible because there is no number 7 on this die. However, the possibility of me rolling a 1, 2, 3, 4, 5, or 6 would be certain because you have to roll one of these 6 numbers when you roll the die. If I was to say, what are the chances of rolling an even number? Well, there is 2, 6, and 4. Those are all even numbers. There's 3 even numbers out of 6. And we know 3 out of 6 is the same as 1/2. So there's an even chance. There's an equally likely chance that I'm going to roll an even number as it is I'm going to roll an odd number. What is the chance that I might roll a 1? Well, there's 1 out of a total of 6. And so there's a 1 out of 6 chance that I am going to roll a 1. So that is unlikely. Okay? It's not a very good chance. However, if I was to say, what are the chances I'll roll a number 1 out of 4? So 1, 2, 3, or 4. Well, that's 4 numbers that I could roll out of a total of 6. So 4 out of 6. 4 out of, we know, means to divide. So 4 divided by 6 gives me 0.67. If I rounded, okay? And we like to make our probability into percents. So times 100 means it's a 67% chance that I would roll a number 1, 2, 3, or 4. And so that gives me, it is likely. It is above 50%, but it is not certain. So probability, a measure of how likely something is going to happen. What are the chances that something is going to happen? So what we just described was theoretical probability. It's defined as what you think will happen. What you think will happen. Okay. It is always calculated as the number of ways the event can happen out of the total number of outcomes in the sample space. So in our die, we have a total of 6 possible outcomes. That would be our sample space. And then the number of ways that the event can happen. So if I wanted to roll a 1 out of a total of 6. If I wanted to roll a 1 or a 2, that would be 2 out of 6. Okay. So here's our 6-sided die. What is the probability of rolling a 4? Well, there is 1 4, the number of the ways the event can happen. So there's only 1 4. So there's only 1 out of the total number of outcomes in this space. So 1 out of 6. And let's change that into a percent. So 1 divided by 6 is 0.16. I'm going to change that to a percent by multiplying it by 100 or moving that decimal 2 places to the right. So there's a 17% chance. Rolling an even number. Okay, so we have the numbers 2, 4, 6. There are 3 even numbers. there are 3 possibilities out of a total of 6. And we know that that simplifies to 1/2, and 1/2 as a percent would be 50%. Rolling a number greater than 2. Okay, so 2, it has to be greater than, so it can't be 2. So 3, 4, 5, and 6. So that's 4 numbers, 4 possible things that I could roll out of a total of 6 possible outcomes. So 4 out of 6 is 0.6. Repeating on forever. So times 100, or move that decimal 2 places to the right, gives me it is a 67% chance. So that is a theoretical probability, what we think is going to happen. But we also have experimental probability. And it's defined as what actually happened. So the only way to do experimental probability is to actually do it, or to look at somebody who has actually done it, look at their results. It is always calculated as the number of times the event occurred over the total number of trials. If you have a die at home, you can do this on your own. So, how many times it occurred? We're going to need to roll our die. Okay, so out of 1 time, I rolled a 3. Okay, so if I was to just go based on 1 roll, what are the chances that I'm going to get a 3? There's 100% chance. That's what the data is showing us, is that there's 100% chance that we're going to get a 3. But we know that if we roll this die again, we probably aren't going to get a 3 again. So let's roll again. Oh, and we did. Okay. So we're still at 100% chance of getting a 3 because it's the only thing that we have rolled. It's not likely that it's going to keep happening though. We know that because of our theoretical probability. Okay, so this time we got a 1. So it's a little less likely that it's going to be a 3. We're just going to roll this about 10 times. The more times you do the experiment, the more, the closer to your theoretical probability that you are going to get. Okay, so out of a total of 4 trials, so we've had 1, 2, 3, 4. 4 trials, that's the bottom. The number of times that it has occurred. Well, we've gotten 3 out of those 4 times. So currently, to roll a 3 out of 4 is saying it's a 75% chance. But we know that on theoretical probability, the chance of rolling one specific number was 17%. It was a lot lower than that. So we're going to continue rolling. Okay, we got a 1 again. So what are the chances of getting 1 at this point? So out of 5 trials, we've gotten 2 1s. So 2 out of the 5 trials is a 0.4 times 100. That is 40%. Okay, so we need to do 5 more times. I'm just going to write them now. Okay, we got a 5. Whoops. A 6. Whoops. A 2. A 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. One more roll. And a 6. So in our 6-sided die, what is the probability of rolling a 4? So according to this, the number of times the event occurred. How many times did we roll a 4? We only rolled a 4 once. Out of how many trials? The total number of trials. So how many trials did we do? We did 10. So 1 out of 10. 1 out of 10 gives me 10%. What about rolling an even number? Okay, so we have 2, we rolled once. 4, we rolled once. And 6, we rolled twice. So that's 1, 2, 3, 4. So 4 out of 10, which gives us 40%. So 40% chance. So notice that's a little bit closer to what we got in our theoretical probability. This is a little closer to the 17%. And then rolling the number greater than 2. So what happened? We had 3, 4, 5, 6, 7 rolls that were greater than 2. So 7 out of the 10. So 7 divided by 10 is 0.7, which is 70%. Whoops, I didn't put a percent there. Which is very close. So the more trials we do, the closer we will get to that theoretical probability, to a point where if we do enough trials, we could actually get that theoretical probability. The more that you try and experiment, the closer to the theoretical probability that you will get. Thank you for joining us today.